All right, in today's lesson, we're going to continue our previous discussion of one-to-one relations and one-to-one functions by taking a look at what are called the inverses of functions. To first understand the inverses of functions, we need to understand what a function is itself. And so we're going to start with our discussion of function notation. So function notation is written as f parentheses x, which is read out loud as f of x, is equal to y. Now there's three key parts of function notation. The first is the name. So the name of our function, and it will usually be f, g, h, and so on. The next is the input. So whatever's in the parentheses is what we're going to be putting into our function. The last is the y value. It's our output. So once we put an input into our function, what we get out of it is the y value. So we're going to take a look just at some basic concepts where we are evaluating our different functions. So we've got three different functions here. The first is f of x is equal to x squared minus 5x. The second is that g of x is equal to 7x plus 4. And the last is that h of x is equal to 2 parentheses x plus 9. All right, so taking a look at number 1. The first thing we want to do is make sure we're using the right function. So it tells us to take f of 3. So what that means is that we're going to take 3 as our x value and put it into our function f. So what that's going to look like is we'll take 3 and square it minus 5 multiplied by 3. In other words, it goes in for x right here and goes in for x right here. So then we just simplify. 3 squared is 9, 5 multiplied by 3 is 15, and 9 minus 15 is negative 6. So our input was 3. Our output was negative 6. This would be the y value at x equals 3. Now let's take a look at number 2. So our number 2, we're looking for g of 3. So the same input, but now we're using a different function. And this time we only have to put it in for x once. So we're going to take 7 multiplied by 3 plus 4. And then again, we just simplify. 7 multiplied by 3 is 21, plus 4 is 25. So our input was 3, but now our output was 25. So if we were to graph this, our x value would be 3, the y value would be 25. Now in number 3, we're going to find h of 3. So we're going to take 3 and plug it in for x in our function h. Again, it's only going to have to go in one place. So we're going to take 2 multiplied by, in parentheses, 3 plus 9. And then we simplify. 3 plus 9 is 12. And 2 multiplied by 12 is 24. All right. On our next 3, we just have to be careful to make sure we're using the right function. On number 4, it actually is asking us for h of negative 5. So we need to make sure that we continue to use h. And we're going to plug in negative 5 for x. So that would be 2 multiplied by, in parentheses, negative 5 plus 9. And now we'll just simplify. So negative 5 plus 9 is 4. And 2 multiplied by 4 is 8. Next, we're going to be looking for f of negative 2. So that means taking negative 2 and putting it into our function f for x. And so we're going to have negative 2 squared minus 5 multiplied by negative 2, which then simplifying becomes 4 plus 10, and our answer is 14. Lastly, for g, we're going to be putting 0 into our function for g, which, as a reminder, g is 7x plus 4. So if we put in 0 for x, we'll get 7 multiplied by 0 plus 4. And then we'll simplify that to just be 0 plus 4. And then that simplifies to just be the number 4. All right. The second concept we're going to talk about is what the inverse of a relation is. So the inverse of a relation is a relation which relates the outputs of another relation to their inputs. To put it simply, it's a way of working backwards. So we're going to look at an example of what this looks like. Given the function below, we're going to find its inverse, f inverse of x, and determine if that inverse is a function. Now you notice that the way we write the inverse of a function is using this notation. So f to the power of negative 1 parentheses x, which again is read f inverse of x. I'm going to fix that over here. All right. So first off, on this left side where we've got our original function, f of x, it's first going to give us a set of points. Now, we have what are called function maps, which is a way that you can show what your function is. So if the first point is negative 1 comma 0, then that takes negative 1 to 0. And the second point is negative 2, 1. Third point is 4 comma 3. And last point is 3 comma 4. It's also asking us for the domain. So we're going to list our x values in order from least to greatest. Notice that that's already in that first part of our domain map. So that would be negative 2, negative 1, 3, and 4. It's also asking us for the range, so we can do the same thing. In fact, the range in that map was already in order for us, so we can just copy those down, 0, 1, 3, and then 4. Let's do the same thing now with f inverse of x. So f inverse of x, we're going to basically take everything and go the opposite direction. In other words, it's going to take all of our outputs and write them as inputs, and all of our inputs and write them as outputs. What that's really going to do is it's just going to switch the x and the y. So if we were to list off the points, instead of negative 1 going to 0, we're going to go backwards and take 0 to negative 1. So then the next point would take 1 to negative 2. The next point would take 3 to 4. And the last would take 4 to 3. And then we can use our function map to draw that out. So we took 0 to negative 1, 1 to negative 2, 3 to 4, and 4 to 3. So now we're going to list off our domain, which again is provided right here for us. So our domain would be the list of values. So 0, 1, 3, and then 4. And then our range, again, we can just list off the values for our range, which are negative 2, negative 1, 3, and 4. One key characteristic that I want to point out to you is that it actually turns out that when you switch the x and y values, something else switches as well, is that the domain of your function becomes the range of your inverse. And the range of your function becomes the domain of the inverse, which should kind of make sense that when you switch x and y, your domain and range are going to switch as well, since the domain and range are based on x and y. Let's take a look at some more examples of this. So number 8, part A, we're given a list of points. Let's go ahead and find the inverse. So we're going to take each of our points and switch them around. So 2, 0 becomes 0, 2. And then we'll have 8, comma 1, 5, comma 3, and 2, comma 6. Now we need to decide, is our inverse a function? So taking a look at our inverse, looking at each of our x values, they all are unique. So yes, the inverse is a function. We can use those x values then to write our domain. So our domain, in order from least to greatest, would be 0, 2, 5, and then 8. For the range, we'll just go through and list the y values in order from least to greatest. And so that would be 1, 2, 3, and then 6. All right. For B, we were given a table. And what we're going to do is something very similar. We're going to switch our x and y values for our table. I'm going to write those as x and f inverse of x. So what we're going to do is we're basically going to just switch the rows of our table. So f of x is going to become x, so that would be negative 2, 1, 2, 1, negative 2, and negative 6. And then f inverse of x is going to be all of our x values, so negative 1, 0, 1, 2, 3, and 4. All right, so now we need to decide, is our inverse a function? So looking at our x values, we actually have some repeats, like negative 2 repeats. The first time it goes to negative 1, the second time it goes to 3. So no, this is not going to be a function. The inverse, anyways, is not going to be a function. However, we can still list the domain and range. So the domain, we're going to list off our x values in order from least to greatest. So that would be negative 6, negative 2, 1, and 2. Remember to make sure that you don't list the repeats. And then for our range, it's actually already in order for us. So that would be negative 1, 0, 1, 2, 3, 4. Let's do a little bit more practice. Let's take a look at how we're going to evaluate inverses. So for each function, we're going to evaluate the values in the table and then determine if the inverse is a function or not. So we're going to kind of put together a couple of ideas. We're first going to evaluate, meaning we're going to take each of our x values and plug it into x in our equation. So on number 9, that would be taking 2 multiplied by negative 2 in parentheses squared minus 1. And then simplifying that, we would end up with 7. Feel free to put that in a calculator or simplify that as you need to. So for negative 1, you would do the same thing, 2 multiplied by negative 1 squared minus 1. And it turns out that that's equal to 1. As you continue to do that, I'm not going to write all of these out, but you'll end up with this as a table. Let's go and do the same thing for number 10. So we'll evaluate, taking negative 2, putting it in for x. We'll have 5 multiplied by negative 2 plus 3, which when you simplify becomes negative 7. Next, we'll do the same thing with negative 1. So 5 multiplied by negative 1 plus 3. And when you simplify that, you'll get negative 2. And again, I won't work through all of these with you, but here are the values for the rest of the table. All right, so now we need to determine if the inverse is a function or not. So we need to decide, is our function one-to-one? And on number 9, clearly it's not. You've got a couple of outputs that are the same, which have different inputs, and so no, the inverse is not going to be a function. However, number 10 is. If you notice, all of your outputs are unique, which means automatically it is going to be a one-to-one function. Now let's do some practice with evaluating the inverse. So what we want to do when we're writing f inverse of our output is actually going to be switched. So the way that our normal function would work, whatever's in the parentheses is your input. When you have the inverse, whatever's in the parentheses is your output. It's, again, everything is backwards. And so what we want to do is we want to find where the y value is 1 for our function f over here on number 9. And if you notice, that actually happens at a couple different places. It happens at negative 1 and it happens at positive 1. We can't write both of those numbers down because it really isn't going to work. And so what we're going to have to write in this case is that it's undefined. There is no value that we can for sure say this is the answer, because we can't decide, we can't just pick one or the other. Not everyone's going to make the same decision. Let's take a look at number 12 though, g inverse of 3. Again, remember 3 is the y value, so what we'll do is we'll find a y value of 3, and then our input was 0, so that's what we will write as our answer. For number 13, f inverse of negative 1, this time there is only one place where f is negative 1, and that happens at 0, so that'll actually be our answer for number 13. For 14, g inverse of 13, we just have to find 13 in our table. That came from the number 2, and there's our answer. All right, one last thing to share in this section is going to be about the evaluating from a graph. This is something that we cover in Algebra 1, but I want to make sure that you remember how this works, as well as show you how it works for evaluating the inverse. So starting off with just evaluating our original function. On number 15, we've got f of negative 1. So remember, negative 1 is your x value. What that means is you go to negative 1 on your graph and figure out where on the function that negative 1 is. And in this case, that happens at a y value of 0. So that would be what we would write for our answer. For f of 0, we would then go to wherever our function is at x equals 0. And in this case, the y value there was 3. So that would be our answer for f of 0. Now, when we want to evaluate the inverse using a graph, remember f inverse of 4 is really our y value. And so what we want to do is we want to look for where is our y value going to be 4. And so the y value is 4 on our graph right here. That happens at an x value of 1. But with f inverse of 3, we're going to run into some problems because there's 2 different points on our function that have a y value of 3. And so just like before, when that happens, we're going to say that this is undefined. Number 16, we're going to do something similar. Notice that this is a different type of graph than we're used to seeing. This is an example of what's called a piecewise function, which is something that we're going to actually study at the very end of this unit. For right now, we're just going to use it to practice evaluating. So if we want to find f of 0, again, that says to go to an x value of 0 and find what the y value is. In this case, that would be up 1, 2, 3, 4. So our answer is 4. Now here's where some interesting stuff happens. At f of 1, notice that there are two different places where our graph is at 1. But only one of those is a filled-in point. And so the one that we're going to pick is going to be the one where we actually have the value. And so that's going to be this point that's still circled, and that has a y value of 2. Next, let's find f inverse of negative 2. So again, what that's going to look for is we're looking for a y value of negative 2, which only happens just once on the graph, and that actually happens at an x value of negative 1, 2, 3, 4, 5, negative 6. And then for the last one, we want to find where our y values are positive 2. Well, that's going to be a problem because we've got a y value of 2 here, we've got a y value of 2 right here, and we've got a y value of 2 right here, so big surprise, we're going to say that that's undefined. All right, so that is it for this section. In the next section, we're going to be talking about operations of functions and average rate of change. Until then, have a good rest of your day.